Okay, so here's part 4 of the Snow Day Makeup Lecture, and this has to do with doing calculations based on pH. Now, in addition to pH, there's this other concept called pOH, which is parts hydroxide. It's not used very often by scientists, but it can sometimes be useful. It is the negative log of the hydroxide ion concentration. And in doing the calculations that I want you to be able to do for the quiz, it's important for you to remember that the hydrogen ion concentration multiplied by the hydroxide ion concentration will always be equal to 10 to the minus 14 power. And that means that the pH plus the pOH will always equal 14. If you keep these in mind, then the math turns out to be really simple. All you really have to do to figure these out is to add and subtract up to 14. It sounds like it's logarithms, but it's actually easier than that. So let's take a look at a problem that we might do. Suppose we've got a pH of 5, and I want you to figure out what the hydrogen ion concentration is, what the hydroxide ion concentration is, and let's also add in here figuring out what the pOH would be. So if the pH is 5, then that means the hydrogen ion concentration must be 10 to the negative 5 power. And since hydrogen times hydroxide has to equal 10 to the minus 14, then that means the hydroxide ion concentration will have to be 10 to the negative 9 power. Which means that the pOH, which is the negative log of the hydroxide ion concentration, is going to be 9. Now, in analyzing this, it helps to convert these into a fraction so that you can tell what these mean. So 10 to the negative 5 power is 1 over a 1 followed by 5 zeros. So basically we're saying the concentration of hydrogen ions is 1 hydrogen ion per 100,000 water molecules. The hydroxide ion concentration is 1 over a 1 followed by 9 zeros. So it's 1 hydroxide ion per 1 billion water molecules, or you could call it 1 part per billion. Parts per billion is a common concentration way of expressing concentrations. So if you remember your fractions, clearly this is a much higher concentration than this one. If you've got more hydrogen than hydroxide, and in this case, what you've got is 10,000 times more 10,000 times more hydrogen than hydroxide. And if we've got more hydrogen than hydroxide, then that means what we have is an acid. So let's do another problem. This time, let's start with a hydroxide ion concentration. Let's try again. With a hydroxide ion concentration of 10 to the, let's make it minus 6. So if this is 10 to the minus 6, then that means our pOH is going to be 6. And our hydrogen ion concentration is going to be 10 to the minus 8. And our pH is going to be 8. So that means our concentration of hydrogen ions is going to be a 1 followed by 8 zeros. Which is 1 part per 100 million. And our hydroxide ion concentration is going to be 1 over 1 followed by 6 zeros, which is a million, or 1 part per million. If we've got 1 part per 100 million for the hydrogen and 1 part per 1 million for the hydroxide, that means we've got a lot more hydroxide than hydrogen. How much more? 100 times more. So we've got 100 times more hydroxide than hydrogen. If we've got more hydroxide than hydrogen, then that means we've got a base. So these are the kinds of calculations that I'm going to want you to be able to do on the quiz.